Welcome back, Math 30-2. Today we're going to look at adding and subtracting rational expressions. Now this here is very similar to something you did a long time ago when you learned how to add and subtract fractions. Here's an example. If you had a quarter of a pizza and I ate 1/5 of the pizza, how much do you have left? And if I ate 1/5 of your quarter of a pizza, how much do you have left? Well, that doesn't make sense, does it? It's 1/4. If I take a look at it, we have 1/4, and we're taking away 1/5. How do we do that? In order to do this, we need equal parts, right? So a lot of you guys cross-multiplied. So this was the same as 5 over 20, subtract 4 over 20, which was the same as 1 over 20. Okay? So you have 1/20th of the pizza left. Alright, so we have to make common denominators. Okay? Now, the same thing goes with rational equations. Now we just have fractions, except there's an x or a y or a z, some kind of variable in it. So it's essentially the same thing. So for a warm-up, all we're going to do is we're going to start by adding and subtracting these fractions. We look at this right here. It's so nice and simple. 5/9 subtract 2/9. They're in the same proportions. So if I have 5/9 take away 2/9, I just subtract the tops, which gives me 3/9, which is the same as 1 over 3. Okay? Let's take a look at the next one. 2/3 plus 3/5. Now here's the problem. It's like saying if I have 2/3 of a pizza and Jimmy gives me 2/5 of his, how much do I have of a whole pizza now? I have quite a bit, but these are not the same size, so I must make them the same size. So this one here, 2/3, I'm going to multiply by the top by 5 and the bottom by 5. If I multiply them both by 5, I keep the ratio the same. Okay, and we plus 2/5. And this I'm going to multiply both by 3. Okay, so now my common denominator is 15, and we're going to add these together. So 2 times 5 is 10, 2 times 3 is 6. So I get 16 out of 15, which is the same as 1 and 1/15 of a pizza. Okay? Or we could just say 16 out of 15. Let's take a look at the next one. We have 5/6 minus 1/4. Well, what's the lowest common denominator of both of these? We could do this in a Venn diagram. There's many ways, or I could just cross-multiply. But that's too much. I'm just going to multiply both of these by 3 and these by 2. Because I think the lowest common multiple is 12. Remember we did lowest common multiples a long time ago? That's essentially what we do. Another way of doing lowest common multiple is doing a Venn diagram. And we have 6, which is 3 and 2. And we have 4, which is 2 and 2, right? So I put the commons in the middle. So there's a 2 and there's a 3 and a 3. And a 2. Whoops. So that is 3 times 2 times 2, which is 6. So this one is 2 and 3, so I have to add and multiply another 2 to this. And I have to multiply another 3 to that to make them equivalent. So what do I end up getting is 10 over 12 subtract 3 over 12, which gives me 7 over 12 as my answer. So this is a very nice way. That's the way I like to do it best and think about it. And you might find it helpful as well. But you could do it other ways as well. It's up to you. So let's take a look at the next question. It says, simplify the following. So now we have x's in there. And we look at this, it's nice. We have common denominators. So all we have to do is subtract. So what is, this is over 3, and we have 2x subtract x. Well, if I have 2 x's and I take away an x, what do I have? I only have 1 x left, so x over 3. A common mistake that students do is they take away the x's and they say the answer is 2. That's not right. You have 2 x's and I take away 1 x, I'm left with 1 x. Let's try this one here. So, common denominator is 4, so we're talking about the same proportions. So I have 3x plus x. Add those together, I'm going to end up getting, I have 4 x's over 4, which is the same as x. Okay? Because the 4's cancel off. Let's take a look at the next one. Again, it's nice. We have common denominators. So this should be fairly simple. It's all over 5. And I have 2a minus 3 plus 9a plus 1. Okay? And these are in brackets if I want. So we're going to combine our like terms. Okay? So if I combine like terms, I end up getting 11a. And plus 1 minus 3 is negative 2, all over 5. So that's how we get that one. All right? Let's take a look at D. Here we have 5y subtract 1, and it's all over 6. So once again, common denominator is 6. So they're all in the same proportion. All right? Same thing as if we have 1. We've always added and subtracted algebra of 1 before. We just add and subtract because the denominator is 1. Or common proportions. So here I have 5y minus 1 subtract 4y plus 7. And we're subtracting all of this. So I'm subtracting 4y from 5y. That's going to give me just y. And then negative 1 subtract positive 7 gives me negative 8. All over 6. That's it. Okay? Alright, now the next bit here is looking a little bit more complicated. If I look at this, we have a problem. What is my problem? My denominators are not the same. So what is a common denominator? Lowest common multiple, we have 4. That is 2 and 2. And we have 10. 5 and 2. What is shared? The 2's. What else do we have? We have 5 and 2. So basically, I have to multiply this by 2, and I have to multiply this side by 5. So we multiply both of these by 5 to keep the same thing, because think of 1/2 is the same as 4/8. That's both multiplied by 4. So let's keep that the same. So we're going to have 6x all over, oh sorry, not 6x, 15x, because we multiply everything here by 5. So that's 15x all over 20, subtract 14x all over 20, because multiply both of these by 2, as we said there. Okay? So this one, because we want the whole thing. Now what do we end up getting? We get 1x, or just x, over 20 is my answer. Okay? Let's try the next one here. We are adding this again, but now we're looking different denominators. So I'm just going to do this one more time down here. So I have 3. Well, the factor of 3 is 3. And then we have 6. That is 2 and 3. So 3 is actually a part of 6, isn't it? So I could just multiply everything here by 2. And we end up getting, multiply the 2 has to go into both, right? Distributive law. So I get 6a minus 2 all over 6 plus 4a plus 5 all over 6. Now I want to combine these. Okay, we could just go like that. So I end up getting, what is 6a plus 4a? That's the same thing as 10a. And negative 2 plus 5 is going to be positive 3. And I can't simplify that anymore. I just leave it like that. Okay? Let's take a look at the next one. C. Alright. We have 8 and 3. Ooh, those don't look very similar at all. So I take a look at this. 8, I have 2 and 4, 2 and 2. 3 is just 3. So if I did a Venn diagram like this, I have 3 here and I have 2, 2, and 2. So there's no overlap in here, so I just have to multiply 8 by 3. So everything on this side is multiplied by 3, everything on this side is multiplied by 8. I'm going to end up getting 3 times 8 is, so my denominator is going to be 24. Okay? 3 times 8 is 24. Y. And 3 times 3 is negative 9. Now on this side, 8 times 2 is 16. Subtract. We have 16. Y plus 8. 8 times 1, distributive law. Okay? Now let's combine like terms. So I have 24y subtract 16y. Well, that's going to give me 8y. Then we have negative 9y subtract 8y. Subtract positive 8y will give me minus 17. That's all over 24. Okay? And that's it. Hopefully you get that. Okay, let's take a look now at example number 4. It says simplify. Oh, well this is interesting. I have a number here. What is this number over? This number's over really 1. So we have 2 and 1. What do I have to do? Multiply everything here by 2. So I'm left with, it's all over 2. I'm going to get 7x plus 3 plus, and this here is 6x. Okay? So I end up with 13x plus 3 all over 2. All right? Let's try the next one. Well, this 4 is really over 1, isn't it? Okay? So I have to multiply both of these by 9, or just this one by 9 to have the same denominator. So I get 36 over 9 minus, because, right, multiply by 9, y subtract 4 over 9. Now I can start subtracting. So that's going to be, what is 36 subtract y? That's 36 subtract y. And then if I subtract negative 4, subtract negative is like adding. So that's like adding 4. So I'm going to get 40 subtract y all over 9. Okay? Now, let's take a look at example number 5. Okay? Here we go. It says, simplify and express in lowest terms the indicated variable. So, simplify and express in lowest terms. Now, we also have restrictions, because if we look at this here, x is on the bottom. So, we know x cannot equal to 0. Now, what's nice about this is I have a common denominator. They're in the same proportions. So let's just solve this. This is all over x. We have 2 plus 7 minus 1, which gives me 9 minus 1 is 8 over x. X still cannot equal to 0. Let's take a look at b. Proportion is kept the same. So, once again, this is just, and we're adding 5a. A cannot equal to 0. 5a, always do that first, plus 3. Okay, and we have to add a minus 6 all over 2a, because we're in the same proportion, so we can just combine them. Now we combine, I'm going to get 6a minus 3 all over 2a. That's it, and a still cannot equal to 0. Now let's try this last one here. We have this and this, same bottoms, right? So I have 3y subtract 1. 3y, and we're subtracting 1. But now y cannot equal to, well, here, I'll solve it over here. So we have 3y minus 1 cannot equal to 0. Therefore, 3y cannot equal to negative, or cannot equal to 1, positive 1. So y cannot equal to 1 over 3. That's important to know. These cancel off, so I have 1. My equation is 1, but y cannot equal to 1 over 3. It's 1. Okay? So let's take a look at class 6. So it says, show that the subtraction of these reduces to 2, and x cannot equal to 3. Well, we know x cannot equal to negative 3. That's already given there. It's x plus 3 cannot equal to 0. So then we know that's my restriction. Okay, so x not equal to negative 3. Now let's try the next part here. Common denominator. So that makes everything so nice and easy. So I have 4x plus 10 minus 2x, put this in brackets now, plus 4, and that's all over x plus 3. Well, what do we get here? What is 4x minus 2x? 4x minus 2x is 2x. Then we have 10 plus 4. So 10 subtract positive 4 is the same as 6. Now I can factor out a 2. And now these cancel off, and there we go. Okay? Now here we are, our very last question before we get on to our assignment. Last style of questions. So it says, simplify each expression notice and state the restrictions. So our first one, p cannot equal to 0. Okay? Now we have different denominators. So once again, what is common? I have 7p and 3p. Well, I have p and 3, p and 7. Breaks it down. So if I look at this, the only thing shared is p. This one has 7, that one has 3. So I have to multiply everything here by 7, and multiply everything here by 3. So I'm going to get all over 21p. 7 times 5 is 35. And we plus 3 times 2 is 6, which gives me 41 all over 21p. There's my answer. Okay? Let's take a look at our next one. So the next one, we're adding 1 over 3y to 6 over 5. So once again, my y cannot equal to 0. Now, if I look at that, say here, we have 3y for 1, and we have 5. Nothing here is related, right? Nothing's related, so we have to multiply both this side, everything by 3y, and this one is by 5 and by 5. So I end up getting, the bottom will be out of 15y, and I get 5 plus 3y multiplied by 6 is 18y. Okay, now I continue this. That can't be simplified, so I have 18y plus 5 over 15y. And that's the best we could do. And y cannot equal to 0, as we stated before. Okay, next question. Here we have 6x and 3x. So let's take a look. Once again, we have 6x. What are the factors? 6 and x. 2 and 3. And we have 3x. That's 3x, which is 3 and x. If I was to do a Venn diagram on this, what's shared? 3 and x. 3 and x. This one has 2. So this side here, we have to multiply by another 2. And this one we keep the same. So this side we multiply both the top and the bottom by 2. Now, the bottom is going to be out of 6x. And by the way, x cannot equal to 0. So we have 6x. And we have 2x minus 5. And what are we subtracting? All of this is multiplied by 2. Distribute along. 6x minus 4. We're subtracting all. Okay? So let's try this out. We have 2x subtract 6x, which is negative 4x. 6x. Then we have negative 5 subtract negative 4, which is negative 1. Okay? Negative 5 subtract negative 4. It's like adding 4, which is negative 1. Alright? So, can this be simplified anymore? Nope. And we know x cannot equal to 0. Last question. Here, let's take a look at this. We have 2a squared. Break that down. That's 2a squared, a. And the other one is 5a. We break this down. We have 5 and a. So what's shared here and what's not? I have a 5, a squared, another 2, and another a there. Okay? So this side we have to multiply by 2a, and this side here we have to multiply by 5. Okay? So what's going to be the bottom is I'll multiply these together. I get 2 times 5 is 10a squared. Okay? 5 times a is 5a. 5 times 7 is 37. Or 35, sorry. And now we have to subtract 2a times 3 is 6a. Okay? So here we look at this. We have 5a subtract 6a is negative 1a. And then we have plus 35 all over 10a squared. In other words, we could also write this as 35 minus a all over 10a squared. That's our answer. And in this case, a cannot equal to 0. Okay? So hopefully you understood adding, subtracting fractions. See you tomorrow as we work on this together as a class.